Hi, welcome to Understanding Complex Exponentials, Lecture 6, Angle Addition and Subtraction Formulas, Part 2. In this lecture, we'll give the answer to the exercise posed in the previous lecture. We'll rederive the expressions for sine of x plus y and cosine of x plus y using a second, simpler method, and we'll also give the angle subtraction formulas. Okay, so at the end of the last lecture, we asked you to derive the relation cosine of x plus y equals the cosine of x times the cosine of y minus the sine of x sine of y. Let's derive this with the same 4 steps as last time. So, Step 1. We write cosine of x plus y in terms of complex exponentials using the relation cosine of theta equals e to the I theta plus e to the minus I theta over 2. So we get that the cosine of x plus y is equal to e to the I x plus y plus e to the minus I x plus y over 2. Okay, next, step 2. We rewrite the exponentials in terms of e to the plus and minus ix and e to the plus and minus iy. So the exponential e to the I x plus y becomes e to the ix, e to the iy. And e to the minus I x plus y becomes e to the minus ix, e to the minus iy. Okay, step 3. We rewrite the exponentials in terms of sines and cosines of x and y. So the factor e to the ix becomes cosine of x plus I sine of x. The e to the iy becomes cosine of y plus I sine y. The e to the minus ix becomes cosine of minus x plus I sine of minus x. And lastly, e to the minus iy becomes cosine of minus y plus I sine of minus y. Okay, and finally, step 4, we simplify our expression. So we had on the previous slide the following. The cosine of x plus y is equal to 1/2 times cosine of x plus I sine x times cosine of y plus I sine y plus cosine of minus x plus I sine of minus x times cosine of minus y plus I sine of minus y. So we're going to use the relations that sine of minus x is equal to minus the sine of x, and that cosine of minus x is equal to the cosine of x. And so we get that the cosine of x plus y is equal to 1/2 cosine of x plus I sine of x times cosine of y plus I sine of y plus cosine of x minus I sine of x times cosine of y minus I sine of y. Okay, so we have that relation from the previous slide. Now let's multiply out all of the terms. So we get that the cosine of x plus y is equal to 1/2 times cosine of x cosine of y plus I cosine of x sine y plus I sine of x cosine y minus sine of x sine of y plus cosine of x cosine of y minus I cosine of x sine of y minus I sine of x cosine y minus sine of x sine y. Now, we have 8 terms there. However, we can see that the imaginary terms will actually cancel out. So, in the first line of the 8 terms, we have a plus I cosine x sine y. And in the second line, we have minus I cosine x sine y. Similarly, in the top line, we have I sine of x cosine y. And in the bottom line, we have minus I sine of x cosine y. So these terms will cancel out. And we can see that what we have left are 2 terms that go like cosine x cosine y and 2 terms that go like minus sine x sine y. And so we get that the cosine of x plus y is equal to 1/2 times 2 cosine x cosine y minus 2 sine x sine y. And the factors of 2 cancel out, and so the cosine of x plus y is equal to the cosine of x, the cosine of y, minus the sine of x, sine of y. So, success. Okay, so the method we used to derive the sine of x plus y and the cosine of x plus y was fairly straightforward, but it was a little cumbersome. Now, let's try to rederive those same relations a bit more elegantly. So let's look at e to the I x plus y a little more closely. E to the I x plus y is equal to the cosine of x plus y plus I times the sine of x plus y. And this implies that the real part of e to the I x plus y is equal to the cosine of x plus y, and the imaginary part of e to the I x plus y is equal to the sine of x plus y. So, if we can write e to the I x plus y in terms of sines and cosines of x and y, we can take the real and imaginary parts of our equation to derive both relations at once. So let's try that. Okay, so we can write e to the I x plus y in terms of sines and cosines of x and y pretty easily. So e to the I x plus y is equal to e to the I x times e to the I y. And e to the I x is equal to the cosine of x plus I sine of x. And e to the I y is equal to the cosine of y plus I sine of y. So we can just write that out and multiply out all of the terms. So we get that e to the I x plus y is equal to the cosine of x cosine of y plus I cosine of x sine of y plus I sine of x cosine y minus sine of x sine y. Now we can group the purely real and purely imaginary terms together. And so we get that e to the I x plus y is equal to the cosine of x cosine of y minus sine of x sine of y plus I times the cosine of x sine of y plus sine of x cosine of y. And now, in order to get the cosine of x plus y and the sine of x plus y, we can just take the real and imaginary parts of this equation. So, the cosine of x plus y is equal to the real part of e to the I x plus y, which is just the real part of the expression we just wrote down, So that's cosine x cosine y minus sine x sine y. Similarly, the sine of x plus y is equal to the imaginary part of e to the I x plus y. And so that's equal to the cosine of x sine of y plus the sine of x cosine y. And these are the same relations that we got before, but the derivation has been much shorter. Okay, so before we finish this section, let's also give the angle subtraction formulas. To do this, we just need to write that the sine of x minus y is equal to the sine of x plus minus y, and the cosine of x minus y is equal to the cosine of x plus minus y. And then we can use the angle addition formulas that we've already derived. So we get that the cosine of x minus y is equal to the cosine of x cosine of y plus the sine of x sine of y. And the sine of x minus y is equal to minus cosine of x sine y plus sine of x cosine y. We would encourage you to confirm these relations on your own. Okay, so now let's give a brief summary. Here's what we've learned in this section. We've given an example of a useful calculation which is simplified by the use of complex exponentials. We've learned two different ways to derive expressions for the sine of x plus or minus y and the cosine of x plus or minus y using complex exponentials. In our second derivation of the angle addition formulas, we saw that sometimes if we have an equation with complex quantities on both sides, it is convenient to write it as two equations, one containing the real part of each side and one containing the imaginary part of each side. In the next lecture, we'll apply the complex exponentials to a real-world physics problem, beats in sound waves.